Actually, the most dangerous places in the universe might not be black holes. Instead, it is those places that are too clean, too quiet, where there is nothing at all, like the Boat's void. It is not that there are no galaxies there, but rather that none of them should exist. There is no gravity, no dark matter, no drag of time. Even light itself becomes colder, slower, and distorted there. So in the time ahead, we will enter the largest silent zone in the universe. Let us see how it freezes time and repels matter, leaving behind an inexplicable cold imprint. Maybe it is not empty after all, but rather, it hides a universe with a truth it does not want us to see. And this whole story still begins in 1977, that year. Astronomer Robert Kirshner pointed his telescope at the Boat's constellation. What he found shocked him. What he saw was utter nothingness. No faint light from distant galaxies, scattered clusters of stars. Not even a trace of cosmic dust exists. Before him lies nothing but bottomless darkness. It is as if even light itself is swallowed here, by accident. He discovered something that, according to all models of the universe, should not exist. This not only shattered his expectations at the time, but also shook the very foundations of cosmology, because according to what we know, when we look into deep space, we should see countless galaxies scattered everywhere. They should be distributed like city lights at night, evenly spread in every direction across the universe. This is a fundamental assumption of cosmology. On a large enough scale, the universe is uniform. Matter should be roughly evenly distributed. Galaxies form a vast, luminous gee woven throughout all of space and time, but the region Kirshner discovered does not follow the script at all. It ignores the rules. It defies common sense. It is as if the entire universe suddenly lost power in this spot. Imagine this. If you shrank the Milky Way down to the size of a coin and tossed it into this void, you would still have to throw in 999 more coins just to barely fill the volume of this space. This void stretches across 330 million light-years. Even light, traveling at nearly 1 billion kilometers per hour, would still need a full 330 million years to fly from one side to the other. It is like suddenly discovering, in the middle of Manhattan, an enormous, completely empty parking lot. And this parking lot is not just bigger than Manhattan, it is even bigger than the entire state of New York. It is even larger than the entire continental United States. This is not just an ordinary empty region. It is more like a space where matter actively chooses not to appear. Without a doubt, this discovery caused a huge stir in the astronomical community. How is that possible? Such a vast space, and yet it is almost completely empty. So where did the matter that should have formed here go? Did it never exist at all? Or was it completely expelled by some force we know nothing about? To commemorate this bizarre and astonishing discovery, Kirshner named this void the Boat's void, a forbidden zone that even the universe itself dares not approach. Other scientists simply gave it an even colder name, the Great Void, or the Cosmic Cold Spot. But the more they observed, the more complex the mystery became. Whether using optical telescopes or radio surveys, they confirmed its existence again and again, and its reality is truly unsettling. This is not some gap between galaxies, nor is it a crack in the cosmic gip. It is itself a massive, tangible void within the structure of the universe. The existence of the Boat's void directly challenges our entire understanding of how the universe formed and evolved, because according to mainstream cosmological models, after the Big Bang, tiny fluctuations in density should have gradually amplified, eventually forming stars, galaxies, and clusters, building up the cosmic structure we see today. But what about the Boat's void? It is as if some force actively cleared out this entire region, making the whole structure seem illogical. One question after another kept popping up. What is it that prevented thousands of galaxies from forming here? Could it be that since the birth of the universe, this place has always been a dead zone? Or is there some mechanism we completely do not understand that cleared out the matter here? And just as Kirshner, as he tried to map the boundaries of this void, he suddenly realized a more unsettling fact. This emptiness was not a formless chaos. It appeared to have direction and outline, even purpose. And at its deepest center, there were actually a few isolated galaxies drifting. They were like lonely islands, suspended in this vast, boundless cosmic ocean. Lies a quiet anomaly, but it is these trapped galaxies that have revealed the true secret of this void. When astronomers made their initial calculations, they found that in such a large void there should reasonably be at least 2,000 galaxies, but actual observations found only 8. You heard that right. 8 galaxies drifting in a space meant to hold 2,000, floating all alone. It is like walking into a concert hall with 2,000 seats, and when the lights come on, you see only 8 people scattered in the farthest corners. That kind of emptiness makes you start to wonder, did you walk into the wrong universe? These 8 lonely stars have also been given a name, the Void Galaxy, but what is truly astonishing is their way of life. It completely breaks our conventional understanding of how galaxies operate. In a normal cosmic environment, galaxies live in groups. They form galaxy clusters and superclusters. They interact with each other through gravity. They prey on and merge with one another. They even share giant dust. Galaxies have social relationships. They are noisy neighbors to each other. But void galaxies are not. They are like hermits in the universe. Each one is lonelier than the last. Where are the neighbors of these galaxies? The average distance is 50 million light-years, but the distance from our Milky Way to the nearest Andromeda galaxy is only 2 million light-years. That is like having your neighbor originally right next door. But now you have to take a train 50 times longer just to meet once. This is cosmic-level social distancing. These galaxies' developmental paths are completely thrown off course. Scientists have found that void galaxies are generally small and dim, as if they have never truly matured. They also contain very low amounts of heavy elements. Their star formation rates are astonishingly slow. It is not that they do not want to shine, but that their surroundings are simply too silent and too lonely. There is no environment they can rely on for support. It is as if they are in a completely sealed room, silently living out their entire cosmic lives. This phenomenon has a technical name, Galactic Underdensity Region, but that cold, clinical term is nowhere near enough to describe the true awe of this cosmic anomaly. These galaxies are not just separated by distance. What lies between them is a deeper kind of emptiness. An isolating force so profound it almost changes their very nature, like a human infant completely cut off from others since birth, growing up in total disconnection from the world. His life's path is destined to diverge completely from the norm. According to mathematical models, throughout the entire universe, the probability of such a large low-density region appearing is less than 1 in a million. In other words, through natural evolution alone, it is almost impossible for such a massive void to form spontaneously. Even in the early universe, when density fluctuations were extremely slight, it should also have been completely leveled over billions of years. Just imagine. It is like flipping a coin 1,000,000 times in a row and getting heads every single time. The odds of that are almost miraculous. Yet the Mufu void exists just like that. For real, standing tall, challenging us. All the fundamental assumptions about cosmic evolution are even more unusual. Those isolated void galaxies also seem to have noticed this anomaly. Their behavior is nothing like the result of random evolution. On the contrary, it seems as if they are being driven by some mysterious force. A race has carved out a void in the fabric of the universe. And when scientists began to closely examine the spatial distribution of these 8 galaxies, the entire mystery instantly escalated. They were not just floating randomly in the void. Instead, they were arranged in a perfect straight line. Imagine an invisible cosmic tunnel, cutting across this emptiness as long as 300 million light-years, and these 8 galaxies are like illuminated subway stations set along this tunnel, evenly distributed along an invisible track. Each one is made up of billions of stars, lighting up the cosmic night like a lighthouse. This is not just a romantic fantasy, but rather a structure that astronomers have actually observed, a cosmic channel known as a filament structure. It actually runs through the center of the entire giant void. Here's the question. In a void with no gravitational sources, no matter aggregation, and no structural framework, how could this line appear in a normal region of the universe? Why are galaxies arranged in a line? It is because they are attached to the cosmic skeleton built by dark matter, but inside the Botart's void, we can't find this kind of skeleton. Instead, we discovered a galactic tunnel like this. What is even more astonishing is that this galactic highway stretches from one end of the void to the other. The average distance between each galaxy is accurate to about 40 million light-years, as if placed precisely by an invisible hand. They are like 8 lamps stretching into the night, lonely yet orderly, illuminating a passage to the unknown. This arrangement suggests that this void may not truly be empty. There must be something we can't see at work here. Is it dark matter, or some other new kind of matter we have yet to discover? Scientists have proposed a hypothesis. This tunnel might be a cosmic fossil, a ribbon of dark matter, left over from the early days after the Big Bang. In the first few billion years of the universe, the distribution of matter was uneven. Certain structures may have appeared briefly, and then dissipated during later evolution, and these isolated void galaxies happened to be located along this early dark matter filament. As the universe expanded, most matter was diluted and drawn farther apart. Only this ghostly clue remains, permanently sealed within the void. What is even stranger is that the movement of these galaxies also supports this theory. They are not just drifting randomly, but seem to be slowly gliding along the direction of this tunnel. Their speeds are identical, their directions are aligned, as if they are being pulled by some invisible cosmic current. The problem is, we have absolutely no way of seeing where this force comes from. Spectral analysis has even revealed that the heavy element content of these galaxies is much lower than that of galaxies of the same age in normal regions. This means that from the very beginning they were born in an environment extremely poor in resources. Their development was both slow and isolated. Like early universe specimens trapped in space and time, this region is like a giant cosmic capsule, preserving evolutionary clues from billions of years ago. And this filamentary structure, maybe this is the only clue to uncovering the truth behind the Mufu void. If we observe this void from the side, what we see is that slender edge. Then those 8 galaxies would appear like a string suspended in the void, a thin line in space, but from most other angles. The arrangement of these galaxies looks so orderly, so that they appear as a single faint point of light. This visual illusion from hundreds of millions of light years away makes this void seem even emptier and stranger than it actually is, even more unsettling. But the truly frightening part does not end there. When we started measuring the rate at which this void is expanding, a deeper mutation is beginning to emerge. The Boots void is not static, it is getting bigger and bigger. Every million years, it becomes even more empty, and the rate at which it expands is even faster than the average expansion rate of the entire universe. Imagine a balloon. You keep inflating it, and there is a small hole on the surface of the balloon. This hole does not burst open. Instead, it expands in sync with the balloon. As the balloon gets bigger, the hole also devours the rubber that should have been there. The behavior of the Mufu void is just like the hole on this balloon. But what it devours is not rubber, but rather the very space that should be filled with galaxies throughout the universe. According to observational data, the expansion rate of this void is about 10% faster than the overall expansion of the universe. That may sound like a small number, but on the scale of the universe, it represents a violation of the fundamental laws of space and time. The expansion of space in normal regions is a gentle acceleration driven by dark energy. But inside the Botets void, what we see is not passive expansion, but rather an active process that drives matter away. A strange repulsive force that pushes galaxies toward the edges of this region. Scientists call this void instability. Once a certain region becomes emptier than its surroundings, matter flows out more easily. Instead of filling back in, the gravity that should have worked there, in these voids, seems to be reversed. You can think of it as a system of water currents in the universe. Galaxies are like water. They usually flow downhill along the slope of gravity. They gather in high-density regions, but in the Botets void, the whole area is like an uphill slope. Matter is guided away, flowing elsewhere. The emptier it gets, the harder it is to attract anything. It just becomes emptier. This vicious cycle eventually leads to an ever-expanding spatial trap. What is even more chilling is, if this trend continues, according to model predictions, within the next 5 billion years, the volume of the cosmic void will expand by a full factor of 2. In other words, when our sun meets its fate and goes out, this void will become even more vast than it is now, and those 8 lonely galaxies will be pushed even farther apart, more scattered and more isolated. But that is not even the most terrifying part. Some scientists suspect that this kind of expansion is not just the result of the universe's natural evolution. Behind it, there may exist some mechanism we have yet to understand, actively driving matter out of this region. The dark energy we are familiar with is the key factor causing the accelerated expansion of the universe. But inside the Botets void, this kind of dark energy seems to be more concentrated. It even forms a sort of cosmic vacuum cleaner, constantly draining the matter density here. Some theoretical physicists have put forward a bold hypothesis. We might be witnessing the birth of a false vacuum bubble in the universe. In this scenario, the physical laws of this void have already changed in relation to the external universe. Its vacuum state is no longer stable, so a local phase transition has begun. It drives the entire region into an inflationary state of new physics. This change not only alters the density of matter, but also changes the way gravity and energy behave. If this hypothesis holds true, then the Boots void is not just a cosmic anomaly, but rather an expanding physical boundary, a crack that lets us peek into the future fate of the universe. Even more bizarre, This kind of abnormal expansion has also changed the way we observe this region. In those voids, the light waves from the few galaxies are stretched dramatically, showing a much stronger redshift than expected. In other words, they appear much farther away than they actually are, dimmer and more hidden. And as the voids continue to expand, this effect is spreading to the surrounding regions. At the edge of the Boots void, scientists have observed an extremely dense cosmic wall structure. It is as if the galaxies, after being expelled from the void, are crowded together at the boundary. Afraid to enter, the galaxies here have a density more than 3 times that of normal cosmic regions. It is like a group of people, frightened by something terrifying in the center of the room. They could only huddle desperately in the corner, and these galaxies on the sidelines no longer float aimlessly. They gather into dense filamentary structures and cosmic sheets, as if at the boundaries, forming a kind of natural sealing belt. Scientists call these structures void walls. They are among the most extreme and most concentrated large-scale structures known in the universe. It is as if the universe itself has drawn a warning line around this anomalous region. These cosmic walls stretch out for hundreds of millions of light years, like gigantic curtains of galaxies, separating voids from the normal regions of the universe. Clearly separated. In certain segments of these walls, the number of galaxies exceeds 10,000, while in a normal region of the same volume, there are usually only about 3,000. This difference in density is more than just a statistical anomaly. It is almost a visible boundary of the universe. Like standing at the edge of the sea, watching the sea spread across the deserted beach. You can vividly feel the shift from presence to absence, from crowded to empty in just an instant. This transitional zone is extremely narrow, perhaps only a mere 20 million light-years wide. On one side are densely packed galaxy clusters, while on the other, it seems like a forgotten vacuum, where not even a trace of starlight dares to approach. But this kind of abrupt boundary completely goes against our fundamental understanding of the distribution of matter in the universe. In the standard cosmological model, the change in matter density should be smooth and gradual, slowly adjusting along the curvature of the gravitational field. But at the edge of the mu floating void, what we see is, but it is a density boundary as steep as a cliff. It is as if some powerful force once carved a cosmic chasm here. Even more strangely, the void wall itself also exhibits some unusual behavior. The movement speed of these galaxies is faster than what models predict. It is as if some force, they are being pushed out from inside the void. This strange pattern of movement suggests some kind of repulsive mechanism we do not yet understand is at work. Physicists call it a negative pressure gradient. It sounds like a vacuum cleaner, but it is not sucking, it is pushing. What is even trickier is that even in the most advanced computer simulations, scientists find it difficult to reproduce such extreme void wall structures using only conventional gravitational mechanisms. This means that these massive walls around the Boots void may require something extra to explain them. Perhaps some kind of exotic matter that has yet to be discovered, some entirely new physical mechanism that we do not understand at all. And these dense walls also affect the way light travels. When light from distant galaxies passes through these regions, it undergoes a slight but measurable gravitational lensing effect, causing the starlight behind the voids to appear distorted, as if we are looking through a cosmic funhouse mirror at them. But the most chilling thing is still those galaxy clusters approaching the edge of the void. The latest astronomical surveys have found several galaxy clusters that seem to be getting swallowed by this emptiness. They are being stretched and pulled apart. Even their star formation patterns have become abnormal. It is as if they are being affected by some tidal force from deep within the void. Torn and shattered, these cosmic walls seem to be a barrier between matter and nothingness. Galaxies desperately cling together, tightly clustered, trying to resist the ever-expanding, dark abyss that devours everything. But to truly understand why these walls appear in the universe, we have to go back to a more fundamental question. Why is there such a vast region that all the matter in the universe has actively avoided for billions of years? The reason the Boots void exists is that in the past 13 billion years, almost no matter has come near it. It is as if it was excluded from the universe right from the very beginning. Behind this escape of matter that has lasted billions of years, there must be a deeper cosmic mechanism at work. We know that there were tiny quantum fluctuations in the early universe. These fluctuations caused some regions to have slightly higher densities. But these differences were extremely subtle, only about 1 in 100,000, normally speaking. As time goes by, gravity gradually smooths out these tiny differences, making the universe more uniform. But in the region of the Boots void, the exact opposite happened. Its low-density state was never filled in. Instead, it got even worse. Matter did not gather here, Instead, it escapes in the opposite direction. In the end, it evolves into a massive void that even gravity can't explain. You can think of the universe as a gravitational topography map, like undulating valleys and hills. In normal regions, the gravitational terrain slopes downward. Matter naturally flows and gathers at the bottom of the valleys, like water. But in the empty regions of the cosmic void, it is like an inverted slope. Not only does matter not approach, it is actually pushed farther and farther away. This is exactly the concept proposed by physicists. Repulsive gravitational field, it is like a cosmic wind of anti-gravity, driving galaxies out this space, which should have been filled with stars. Yet, we still can't determine the true nature of this repulsive force, but one possible explanation points to the most mysterious presence in the universe. Dark energy. Dark energy is the driving force behind the accelerating expansion of the universe. It is generally believed to be evenly distributed throughout the universe, but some theories suggest that under extreme conditions, it may accumulate abnormally in certain regions. The mu void is such an area of dark energy overdensity, then it would generate a strong repulsive force, directly pushing normal matter out of this space, creating a truly empty void. Another explanation is even more peculiar. It involves a strange state of matter that may have existed in the early universe. In the very first moments after the Big Bang, the universe may have undergone a series of violent phase transitions, like water suddenly freezing into ice. If certain regions were trapped in different phase states during this process, this could result in spaces with completely different physical properties. Pocket voids. Maybe that is what they are, regions where dark matter never managed to condense successfully. We know that dark matter forms the gravitational framework of the universe's structure. Galaxies and galaxy clusters are born attached to this framework. And once a certain region is missing this framework, normal matter can't gather there either. The result is that there are no galaxies, no structures at all. Only eternal emptiness remains, and our observations of the cosmic microwave background happen to provide evidence for this explanation. The ancient light from the Big Bang. In the direction of the Eridanus void, there is a distinct cold spot. This means that this region has been problematic since the universe was only 380,000 years old. It was already an anomalous area back then. This cold spot is like a fossil from the ancient origins of the void, reminding us his anomaly had already been foreshadowed since the universe's infancy. What is even more unsettling is that computer simulations show to form such an extremely low-density void, the initial conditions required across the entire statistical range of the universe are almost impossible to occur. The probability of forming such a void through random long falls is less than 1 in 10 million. This means that the mu void is very likely not a byproduct of random cosmic evolution, but rather an organized, systematic early physical process that left its imprint on the universe. Some theoretical physicists have therefore proposed that during the period of cosmic inflation, this region may have experienced a unique expansion mechanism. The original purpose of inflation was to smooth out primordial irregularities, but in very rare cases, it might also work in reverse. Differences are pushed to the extreme. As a result, some regions are pushed into extreme emptiness, while others are squeezed into deadly density. And as we delve deeper into the impact of this emptiness on the entire structure of space-time, things become even stranger, because a cosmic void is not just a space without matter. He even changed the very shape of space itself, even the way time flows. According to Einstein's general theory of relativity, any matter and energy will cause space-time to curve. And the gravity we feel is precisely the manifestation of this curvature. Massive celestial bodies like stars and planets create dents in space-time, and in regions where matter is scarce, only a slight curvature is left behind. So here's the question. If there is an area that is almost completely empty, how would it change space-time? The answer is that such a void creates a kind of negative curvature, which is a geometry that bulges outward. Unlike galaxies that compress space, the void seems to prop up space and time, turning it into a cosmic saddle. And this kind of geometric inversion not only affects the shape of space, but also disturbs the path of light and can even alter the flow of time itself. When light passes through a cosmic void, it does not travel in a straight line as it does in normal space. Instead, it bends slightly along this outward bulging region of space. The geometry deviates from a perfect circle. As a result, the light from background galaxies spreads out more as it travels. It becomes more diffuse, blurry and dim. It looks as if it has been stretched or thinned out. The Botis void is like a reverse cosmic magnifying glass. It makes the starlight appear farther away, smaller, and more ethereal. This is the reverse effect of gravitational lensing. It becomes our basis for direct evidence of whether a void truly exists. Even if there is nothing there, it can still distort the path of light. Even more astonishing, time itself is affected within this void, also runs a bit faster. According to general relativity, closer you are to a dense mass, the slower time passes, but in regions with weaker gravity, time speeds up slightly. Since the Boots void contains almost no matter, the cosmic clock inside it moves slightly faster than in densely packed galactic regions. Although this difference is extremely small, it may be only 1 per 100,000, but it reveals a deeper issue. Our understanding of time might be overly simplistic, and this void is more than just that. Recent research shows that when gravitational waves pass through the Boots void, their amplitude and frequency will also undergo subtle changes. Gravitational waves are ripples in space-time. They were first detected by humans in 2015. They travel at the speed of light, passing through the entire universe, but when they enter this region of negative curvature, they get stretched and distorted. Future gravitational wave detectors, it may be possible to use this disturbance signal to map out the entire three-dimensional structure of the void, and this structure can also trigger a peculiar phenomenon, the gravitational Doppler effect. When photons climb out from the gravitational well at the edge of the void, they lose a small amount of energy, which appears as a redshift. This is not the kind of redshift caused by the expansion of the universe. It is actually due to the void itself having an additional effect on the energy of photons, and precisely because this effect exists, we have to be even more careful when measuring the distances to distant celestial objects. We must be extra cautious, because even if light passes through the void, it won't emerge completely unscathed. Some theoretical physicists speculate that inside the Boots void there may exist a strange form of matter we cannot directly observe. These hypothetical particles may possess negative energy density, thereby creating a repulsive gravitational effect, which might explain why this void is so extreme. This exotic matter is still only a theoretical conjecture for now, but once it is confirmed, it will completely overturn our current framework for understanding the forms of matter in the universe. Moreover, this hollow space-time structure would also affect the paths of cosmic rays traveling through it. Those high-energy particles that set out from distant galaxies, when passing through this region of warped gravity, trajectories will be bent. In some areas, it can even create signal blind spots. In other words, cosmic rays will be deflected and blocked, deviating from their original paths. And this gravitational interference is not limited to the void's interior. It even extends beyond the void itself. It affected the cosmic microwave background radiation, that afterglow from the early days of the Big Bang. The Eridanus supervoid is like a shadow cast on this baby picture of the universe. This means that, as early as when the universe was only 380,000 years old, this void, it has already begun to affect the structural evolution of the entire universe. Originally, the cosmic microwave background should be almost uniformly distributed across the whole sky, with only slight temperature fluctuations reflecting tiny disturbances in the early matter density. But in the direction of the WMAP cold spot, we observe an unusually cold region, spanning several degrees across the sky. It is one of the most prominent and distinct cold spots in the entire cosmic microwave background, although its temperature difference is only 1 per 30 million of a degree. This extremely tiny deviation is an unprecedented cosmic fingerprint. It tells us that as early as the formation of the universe, the density in this region was already abnormally low, and the cause of this cold spot is related to a mechanism called the Sachs-Wolf integral effect. When photons pass through regions where the gravitational potential changes over time, if that region continues to become emptier as it evolves, the photons lose energy as they escape and become colder. The void of the mu-fu perfectly meets these evolutionary conditions. It is like a cosmic trap that absorbs energy. Every ancient ray of light passing through it has to pay an energy tax. This effect has persisted for over 13 billion years. Eventually, in the cosmic background radiation, it left behind a cold imprint, and the temperature and extent of this imprint. It has also become an important clue for scientists to trace the evolutionary history of this void. Through precise modeling, researchers have found that, in the early universe, the Shogunate void may have been just a small, low-density region, but as the universe expanded and gravity took effect, it gradually evolved into the colossal structure we see today. But the problem is, the temperature of the cold spot is not as low as theory predicts. According to the standard cosmological model, it should be twice as low as the temperature we observe now. This means either our model is incomplete, or within this void, There really is some unknown physical effect at play. Some scientists have suggested that perhaps the cold spot signal was contaminated during transmission. As photons pass through the void, they encounter high-energy gamma or other sources of interference and regain a bit of energy, making them appear not quite as cold. Other than that, the size of the cold spot also provided more clues. By analyzing the temperature distribution in different directions, scientists discovered that we are almost directly facing this void as we observe it. That is why we can clearly see its full extent, spanning 300 million light-years. Other voids also leave traces in the cosmic microwave background, but none are as clear as the boat's void. Vast and profound, this further proves that the boat's void is not some accidental gap, but one of the most extreme low-density structures in the universe. It even affects our understanding of dark energy. The temperature patterns revealed by the cold spot provide additional evidence for the existence of dark energy. Also helps us constrain key parameters in inflationary models. But ultimately, we still have to face that unsettling question. Is the boat's void an isolated supervoid? Or is it a new type of cosmic structure we have yet to understand? The existence of the boat's void, it is like an echo chamber left behind by the universe itself. The more we try to hear its voice, the deeper its silence becomes. It is not emptiness, but a silence so absolute. It feels as if something is being concealed. Behind this void spanning 300 million light-years, there may be a cosmic script beyond our understanding, a physical law yet to be activated, a long-forgotten cosmic memory, or perhaps a door that has never truly opened to humanity. When we gaze up at this emptiness, what are we really looking at? Is it the absence of matter, or denial of existence itself? Perhaps the universe is not missing a piece at all. Instead, he deliberately left an empty seat there, waiting for something, an older consciousness than ours to return.